Hey everyone, today we are going to solve this really amazing, mind blowing problem of trigonometry. This is a very old problem. I came across this when I was studying for IIT JEE, and I think it was around 14 years ago. And I have to admit that I could not solve it for many days. I was completely stumped, and finally, I had to go to my teacher to ask for the solution of this problem. So, what is so special about this question? One of the things that we can notice here is the angles that we are dealing with: pi over 9, 2 pi over 9, and 4 pi over 9. These are not standard angles. The value of these angles is 20 degrees, 40 degrees, and 80 degrees. And these are not standard angles. So we cannot find out the trigonometric ratios of these angles, and that is just surface of this problem. So what we are going to do here is that we will try to convert these angles into some nicer angles or standard angles, and then we will proceed from there. But before we start solving, I have a very small request. Please do subscribe to the channel if you are already not subscribed. Okay, so let's see what we can do here. First and foremost thing, what I'm going to do is that I will try to convert these non-standard angles into some nicer angles. So we have first angle pi over 9, second angle 2 pi over 9, and third angle is 4 pi over 9. What we can do is, if we multiply these three angles with a common factor of 3, multiply these three angles with 3, the first angle becomes pi over 3, second becomes 2 pi over 3, and the last one becomes 4 pi over 3. And these are obviously standard angles. This is 60 degrees, this is 120 degrees, and the third angle is, I think, 240 degrees, right? That is not the end of manipulation. There is one more thing that we can notice from here, that if we take the tan of this new tripled angle, tan of pi by 3 is equals to square root of 3, tan of 2 pi over 3 is equals to negative square root of 3, and for the last one, tan of 4 pi over 3 equals to square root of 3. So we can notice two patterns. One is that all these three angles are getting converted into nice standard angles by multiplying with the same factor 3. And there is one more thing, that the tangent of these tripled angles is coming out to be same or almost same. For the second angle, we have a small problem of negative sign, but in trigonometry, positive negative are very small problems. We know that we can manipulate these angles to remove this negative sign. So what I'm going to do here is that the second angle, which is 2 pi over 9, we know that cot square of theta is also equals to cot square of pi minus theta, and that is what we are going to do here. This is a very small manipulation, but it's going to be super useful. So what I'm doing is that instead of using the angle 2 pi over 9, I will use the angle 7 pi over 9. And the reason is that if you multiply 7 pi over 9 with the factor of 3, you get the angle 7 pi over 3. And the amazing thing about this angle is that its tangent is also coming out to be square root of 3. So we have the established pattern. Multiply each angle by 3, take tan, and we get a nice square root of 3 in all the three cases. So what is going to be the next step? I am dealing with the angles pi over 9. Instead of 2 pi over 9, I'll say 7 pi over 9, and the last angle is 4 pi over 9. I will multiply these angles by 3. So if I represent these angles by theta, I'm trying to say that tan of 3 theta equals to square root of 3, and this equation is satisfied by all these three angles, right? Tan 3 theta equals to square root of 3 is satisfied by all of our three angles. So this is the main idea that we are going to use here. Tan of 3 theta equals to square root of 3. We know the formula for tan 3 theta. We will use the identity tan of 3 theta equals to thrice of tan theta minus tan cube theta over 1 minus 3 tan square theta. So we will get a cubic equation. We will get a cubic equation in terms of tan theta. And the beautiful part about this cubic equation is that this cubic equation has three roots, which are the angles theta 1 equals to pi over 9, theta 2 equals to 4 pi over 9, and theta 3 equals to 7 pi over 9. And we are very much interested in these three angles, right? These three angles were the angles from which we started our problem. Right, so we have a cubic equation and we have idea about the roots of this cubic equation. So let's solve it a little bit. And before solving, I want to do a very small substitution. I want to substitute tan theta with a more friendly looking variable x. So we are getting 3x minus x cubed over 1 minus 3x squared equals to square root of 3. Let's simplify it a little bit. We will get from here x cube minus 3 root 3x squared minus 3x plus square root of 3 equals to 0. This is a cubic equation that we are getting, right? This is a cubic equation that we are getting. And let's see what we can do here. The beautiful thing about this cubic equation is that the roots of this equation are x1 equals to tan pi over 9, if you remember the angles, x2 equals to tan 4 pi over 9, and x3 equals to tan of 7 pi over 9. Right, these are the three roots of this cubic equation. Now one last manipulation, just last manipulation, I promise. We are more interested in finding some kind of relation for cot of these angles, cot of pi by 9, cot of 4 pi by 9, and cot of 7 pi by 9. So instead of directly solving this particular cubic equation, I will do one more manipulation, the last manipulation. I will substitute x by 1 by x, so that in the resulting equation, we have the three roots as cot pi by 9, cot 4 pi by 9, and cot 7 pi by 9. Because if we substitute x by 1 by x, the roots of the equation will also become the multiplicative inverses of the original roots. So I'm trying to say that if we do this, 1 over x cube minus 3 root 3 over x squared minus 3 over x plus the last term is the square root of 3. For this cubic equation or cubic looking equation, the roots are going to be cot pi by 9, cot 4 pi by 9, and cot 7 pi by 9. And I think now you got the idea what we are going to do here. Let's simplify it. So we will get square root of 3x cube minus 3x squared minus 3 root 3x plus 1 equals to 0. The roots of these three equations, this cubic equation is going to be x1 equals to cot of pi over 9, x2 equals to cot of 4 pi over 9, and the last root x3 equals to cot of 7 pi over 9. And if you remember the original question, we really are interested in finding the value of x1 squared plus x2 squared plus x3 squared. And this is very simple to find out using theory of equations. We know that x1 squared plus x2 squared plus x3 squared is basically the square of sum of the roots x1 plus x2 plus x3 whole squared minus twice of x1 x2 plus x2 x3 plus x3 x1. And from here it's really simple to simplify. We know that sum of the roots is given by 3 over square root of 3. We are using theory of equations to find the sum of roots minus twice of sum of roots taken 2 at a time. So for this cubic equation, sum of roots taken 2 at a time will be negative 3 root 3 divided by square root of 3. Negative 3 root 3 divided by root 3. And we can very easily simplify it. Square root of 3 squared, that is 3 plus 6, and the answer is coming out to be 9. And we know the values of x1, x2, x3. These are basically cot pi over 9, cot 4 pi over 9, and cot 7 pi over 9. So effectively what we are getting is cot square of pi over 9 plus cot square of 2 pi over 9. I am replacing 7 pi over 9 with 2 pi over 9 one more time. So this is what we are getting. This is our answer. We are getting cot square pi over 9 plus cot square 2 pi over 9 plus cot square 4 pi over 9 equals to 9. This is the answer. So I really hope you guys liked this question. This was really amazing to solve. And we used a lot of manipulations, trigonometric manipulations, as well as algebraic manipulations to solve this question.